It's Algebra 2, Lesson 56, Solving Systems with 3 Variables, second day. Same steps as yesterday. These are your steps, so you should have them in your notes ready. Here we go. I'm going to do 3 problems for you. First one, number 1. You could follow along if you need to, or copy as you go, because these take the whole page, okay? So I recommend you do take it. So number 1, I'm going to make a little space here. First thing I always do is I ask myself, or I organize my info, 1, 2, and 3, equations 1, 2, and 3. Then ask myself, which variable do I want to eliminate first, okay? I want to focus on the easiest one, okay? So the easiest one, the x's are all different. So the LCM of all the x's would be 12. That's too hard. But if I look at all the y's, they're all 3. That's real nice. The z's would be also 12. That's the LCM. So I don't want to do that. So the first thing I'm going to do is I'm going to take equations 1 and 2 and put them together. So we're going to eliminate some y's right now. So we got negative 4x plus 3y minus 4z is equal to negative 4. Equation 2 is negative 4x minus 3y plus 3z is equal to 24. Okay, so I'm focusing on my y's right now. I want to know how do I eliminate these y's. So I'm going to add the second equation because I know if I do that I eliminate these y's here. So negative 4x plus negative 4x is negative 8x. The y's are eliminated. Negative 4z plus 3z is negative z, and then negative 4 plus 24 is positive 20. Okay, so I just made a new equation. This is equation 4. Okay, continuing on. Now I'm going to do 2 and 3 together. Equations 2 and 3. Okay, we have negative 4x plus 3y plus 3z is equal to 24. That's equation 2. Equation 3, right underneath it, lining it up, is 3x minus 3y minus 2z is equal to negative 17. Bless you. Okay, so focusing on still the y's. I don't want to work on anything else here, so I'm going to add the second equation to the first equation, and I get negative 7x. Is that right? No, I'm... Huh?
It was minus 3y for equation 2.
Oh, yeah. Sorry. Minus 3y. Thank you. Right here? Like that. Oh, thank you. I was wondering because my notes look different. Okay, so when I do that, I'm going to use the subtraction sign. So we got negative 7x. These two cancel out. Positive 3z minus negative 2z is positive 5z, which is equal to 24 minus negative 17 is positive 41. This is equation number 5 now. Okay, so now we have 2 equations, 4 and 5. So now I want to focus on my next equation or next variable. So what variable is easier to work with, the x's or the z's for 4 and 5? I'm thinking ahead. The z, right? But they're different, right? It's 1z and then 5z, right? The LCM of the z's is 5. The LCM of the 8 and 7 is 56, so we don't want to use that one. So we're going to go use the z's, okay? So I know that if I look at negative 1z right here, that there is 1z, and over here we have 5z. So I'm going to multiply this whole equation 4 by 5 so that I could have the same number of z's, okay? So we have equation 4 will be negative. Sorry, I'm going to rewrite it. Rewriting equation 4, converting it, it's going to be negative 40x minus 5z is equal to 100. And then equation 5, you're just going to leave it the way it is because it's already good to go. Okay, so when that's the case, use a plus sign. And we figure out the z's cancel out, so we got negative 47x is equal to 141. Now that's a big number. If I divide both sides by negative 47, what's x equal to? No, negative 3, right? Okay, so sometimes you're going to have bigger numbers like 141 and 47. They're a little bit more difficult to work with. Use your calculator, okay? Pause that. Okay, so since we know our x, we could plug it back into one of the two equations. I'll go back to the original equation 4. So I'm rewriting equation 4. We have negative 8x minus z, so it's negative 8x. So instead of x, I'm going to put negative 3. Minus z is equal to 20. So we have 24 minus z is equal to 20. So negative z is equal to negative 4. So z is equal to positive 4. Okay? So that's for z. Now that we know two of them, you could go back to one of the two equations at the beginning or three equations. I'm just going to plug it back into equation 1. So we got negative 4 times negative 3 plus 3 times y, or 3y minus 4 times 4 is equal to negative 4. Sorry, I'm going at the end of my paper here. So we got 12 plus 3y minus 16 is equal to negative 4. 3y minus 4 is equal to negative 4. And then 3y is equal to 0, or y is equal to 0. Sorry, it's getting hidden back there. Okay, so but your solution is going to be three numbers. It's going to be x, y, z, so negative 3, 0, and 4. Okay. So in this example, I want to show you this example because it shows you that sometimes you have big numbers to deal with, and you have to use your calculator on this type of problem. Okay. Now, once you're motoring through this and you're doing it more quickly, these problems shouldn't take you very long, okay? Well, they do take a little bit of work. There is a lot of writing, I know, but once you're motoring, like I said, you're going to go really quickly. Yes. 2. Okay, so number 2, here's another example. Okay, same thing. For number 2, you always start off by naming your three equations. We got equation 1, equation 2, equation 3. Then I ask myself, what variable do I want to eliminate? I look at the x's. What's my LCM of all these x's? Well, it's 60. It's all my y's. What's 4? That's pretty good. What about the LCM of my z's? What's that one? 6. That's okay too, but I think I want to stick with my y's. Why do you think that? Huh? Good, because it's smaller. Okay? So, we want all my y's to be equal to 4. Okay? So, starting off with 1. Let's just start over here. You got 4x minus 4y minus 2z is equal to 14. Number 2. Okay, I got to convert it so that the y's are 4. So what do I multiply equation 2 by? 2, right? So we're going to multiply this by 2. So we got 12x where is this? My notes. Oh yeah, there it is. 12x plus 4y plus 6c is equal to 14. Okay? So, now that my y's are the same, I'm focusing on my y's. I want to eliminate them, so I'm going to add them. So I got, what I'm left with is 16x plus 4z is equal to 28. This is equation number 4. Okay? Do the same thing with 2 and 3. Since I already converted 2, I'm just going to recopy it. Got 12x plus 4y plus 6z is equal to 14. Then equation 3, what do I need to multiply equation 3y to get 4y? Look back at equation 3. What would I need to do to modify equation 3? Multiply it by 4. Okay, so we got 20x plus 4y plus 8z is equal to 28. And I want to get rid of my y, so I'm going to subtract. So we got negative 8x. Y's cancel out. Minus 2z is equal to negative 14. Okay, so this is equation 5. Now look at 4 and 5. Which variable do you want to focus on between equation 4 and 5? X's or z's?
Z's.
Okay, z's. Okay, so are my z's the same right now? Yes or no?
No.
No. Okay, so what's my LCM for my z's? No. We're talking about z's. There's a 4 here, and there's a 2 here. Which one is my lowest common multiple? What can I do? 4, right? Okay, so since equation 4 is already has a 4z, I'm not going to convert it. I'm just going to copy it. So we got 16x plus 4z is equal to 28. Okay, equation 5, I'm going to multiply by 2, so I'm going to have negative 16x minus 4z is equal to negative 28. Okay, now what are you noticing about these two equations right now before I do anything? Yeah, they almost look the same, but they're opposites, right? Do y'all see that? So which variable do you want to eliminate, x's or z's? What? Okay, so eliminate the x's. So I'm going to put a plus sign here. X's are eliminated. Oh, left with 0. 4z plus negative 4z. Oh, that's left with nothing, right? We're just left with 0 on one side. 28 minus 28 is 0. So if I have 0 is equal to 0, let's recall back when we did systems. Good, we said all real numbers, or another way, it's a little more accurate. Let's just put infinite solutions. Okay, infinite, meaning there are endless numbers of solutions you could put in here. And the reason why is because, remember yesterday I talked about the x-axis, y-axis, and then the z-axis, the three-dimensional coordinate field. We have, on this example, it's 3 planes that are exactly the same plane. They just all have different numbers. They all cross at infinite points. Okay? Yeesh. That's it. Yeah, we know at this point that it's infinite solutions. Okay? Continuing on. Oh yeah, so actually before we continue, I want you to turn to your neighbor and talk about this example, why it's infinite solutions. That way you get it ingrained in your brain. Ready, set, go. Number 3. Now number 3, if number 2 was about infinite solutions, what do you think number 3 might be about?
No solution.
Maybe no solutions. Okay. So we don't know that yet though. So I'll tell you how that works, okay? You're like, "Oh, I'm tired of doing this." Shh. Quiet. So, first thing I do, of course, is always I'm going to name my 3 variables. We got variable, or not for variables, 3 equations 1, 2, and 3. Okay, and we look at the at our numbers. Okay, x's. What's my LCM of all my x's? 15. What about my y's?
15.
What about my z's? Okay, let's just focus on my z's then. Let's make that our focus. So, start with 1 and 2. So, 1 and 2 needs to be multiplied by 3, right? Because we want it to be 3z. So, I'm going to multiply the first one by 3. So, we got negative 15x minus 15y plus 3z is equal to negative 45. Then we got equation 2. It's going to be negative 15x minus 15y minus 3z is equal to 18. I'm going to focus on getting rid of those z's. So now something smells a little fishy to me already because the numbers are very similar, but it doesn't mean that it's infinite solutions yet. You have to prove it by showing 0 is equal to 0. So focusing on the z's, I'm going to put a plus sign. So negative 15x minus plus 15x is going to be negative 30x. Then it's going to be negative 30y. Z's cancel out, and then we have negative 27. Okay, that's cool. Shh. This is equation 4 now. Okay, now we're going to do the same thing with 2 and 3. I already got 2 all set up, so it's going to just copy it, negative 15x.
Yeah, it's like 5 years.
Minus 15y minus 3z is equal to 18. Equation 3 is just, you just copy it again. It's just going to be 3x plus 3y minus 3z is equal to negative 21. Okay? So, I'm going to focus still on the z's. Okay? So getting rid of those z's, I'm going to put the subtraction sign here because I want to get rid of. They cancel out there, and then we got negative 15x minus 3x is negative 18x. Shh. The y's turn into negative 18y. And then this equals to 39. Now, this is equation 5. So now we have to bring 4 and 5 together. What is the LCM for x's and y's in 4 and 5? A really big number, right? We have 18 and 30. So that's if we multiply. So this example, this is the first point of this example, is that sometimes, why don't we just not multiply? Let's just divide, even if you have to deal with a fraction, okay? So here we go. What's the LCM of 30 and 18, or what is a factor, a common factor of 18 and 30? 6, right? So let's just do that. Greatest common factor is 6, okay? So, what do I need to divide equation 4 by to get 6? Well, I divided by 5, okay? So it's going to be, equation 4 I'm going to convert. Watch carefully. It's going to be negative 6x minus 6y is equal to, and you're like, oh, fractions. Don't worry about fractions. Just get used to them. They're only going to be around for the rest of your math career if you take calculus. Okay? Shh. And then equation 5, what do I multiply or divide 5 by? What do I divide equation 5 by? What do I divide equation 5 by? 3, right? So then we got negative 6x minus 6y is equal to what? What's 39 divided by 3? 13, good. Okay? Now, I'm going to put this around. We're going to get rid of the x's or the y's. Okay, so we're going to do a subtraction sign. Negative 6x minus negative 6x cancels out. Negative 6y cancels out. So you get 0 degrees. 0. Okay? Now, negative 27 over 5. This is really like saying negative 5 and 2/5, right? So what's negative 5 and 2/5 minus 13? It's negative 18 and 2/5. Now, who cares it's fractions? Let's just look at the concept here. Does it make sense that 0 is equal to negative 18 and 2/5? No. So what did I teach you last week about this? What? No solution, okay? So, Whenever you're at this point where something is equal to something else, that's not true, then you know it's no solution. Okay? Does that make sense? Yes? Okay, so there are two things I want you to take note from. Listen, and sometimes you're going to have to divide, and sometimes it's better to deal with a fraction than to deal with a big number. Would you rather have a big number and no fractions, or would you rather have a smaller number and have fractions?
Small number.
Okay. First period was the opposite. They all wanted big numbers. It's like, no, fractions are better. Okay, get used to them. They're actually easier to work with. You could actually use all these as fractions. You could have done number 1 by dividing everything by 3. Right? You see that? No, we could have done that right. Okay. All right. So, turn to your neighbor. That concludes the lesson, but I want you to talk about this with your neighbor.